Okay, so we are now getting down to a topic in corporate finance called time value of money as we wrap it up. Okay, I know Mr. Njovu could have started it at the time, but we are now looking at the time value of money. And in particular, we look at annuities. What's an annuity? All right, then getting down to the other part of this problem. Okay. So as we're looking at this, we are simply saying an annuity is a series of equal payments or equal deposits is what we call an annuity. Annuity is a series of equal payments or equal deposits. Okay, or an annuity represents a series of equal payments or receipts occurring over a specified number of equidistant periods. And of course, there are two types of annuities. We have ordinary annuities, an annuity where payments or receipts are made or occur at the end of each period. That is just about an ordinary annuity. An annuity where payments or deposits occur at the end of each period or the month. And our annuity due is this is where payments or receipts occur at the beginning of each period. This is how we look at an annuity due. It's okay, so it's an annuity where we're talking about payments or deposits are being made at the beginning of each period is what we call an annuity due. All right, so this is just about the distinction between an annuity due and ordinary annuity. All right, so if you're making a deposit at the beginning of the period, it's called an annuity due. So ordinary is where payments or deposits are made at the end of the period. So ordinary annuity, you want to get, after you get your salary, you instruct the insurance company or rather the bank to deduct money as a stockholder, standing order, that every month that you get paid, they deduct a 500 quarter from your salary as you are reserving, keeping it towards a certain project, or maybe your child wants to go to school in the shortest possible time, or in 2 years' time. Then every month when you get paid, they deduct 500 kwacha. That 500 kwacha, if it is at the end of the month, they are deducting, it becomes an ordinary annuity. So when finding the present value interest factor of that annuity, then is equal to the formula is equal to amount, then open brackets 1 minus 1 plus r to the power negative n, okay, then over r. This is just about how you get to the present value interest factor of that annuity. All right, so this ordinary is where payments or deposits are made or done at the end of the period. Then we have the future value interest factor of annuity is actually equal to amount. Then here we have 1 plus r to the power n, okay, minus 1 over r. This is on the future value interest factor of an annuity. And we're talking about this annuity is a value or the amount that has been that is being deducted at the end of the period or the month, and we need to find the present value of that deduction. We have these formulas up. For the first one is the present value interest factor of an annuity. Then the other one is the future value interest factor of that annuity. So these are the two formulas that we need to understand as we get down to this. Then we have annuity due. Okay, so annuity due, we are simply saying this is where payment or deposits are done at the beginning. So this is at the beginning. then the other one is at the end. Okay, so we have this at the beginning of the period, then the other one is at the end. So to find the present value interest factor of that annuity is actually going to be amount of that annuity, then 1 minus 1 plus r to the power negative n over r, then whatever the expression we have here multiplied by 1 plus r. So this is about the formula to use as we look at present value interest factor annuity due. We use this kind of the formula. Then getting down to the other one, the future value interest factor of annuity due is actually equal to amount, then open brackets 1 plus r to the power n, then minus 1 over r, then multiplied by 1 plus r, just like this. So, and because of the fact that this beginning, we have an extra interest coming from day 1 to the 30 days. Because we are acquired, the interest is there from day 1 to, this is where this applies, because we have the amount acquires or requires or applies or has gotten the entire interest from the period of day 1 to the other period. This is why we are talking about this one getting down to this kind of a problem. All right, now an ordinary annuity forgoes the interest for ordinary because this is at the end. So meaning that from day 1 to the last day, you only the interest is at the end of the month, at day 30. Okay, so meaning that it has forgone the interest. All right, so it has forgone the interest because this is just done at the end of the period. So please take note of the distinctions between the two, ordinary annuity and annuity due. At the beginning, the interest applies from day 1, the very day 1, up to day 30. All right, so this is just about what goes on. Then we have the what we call perpetuity. Perpetuity is a continuous cash flow. Okay, so we have what we call perpetuity, which is on aspect of continuous. Okay, so this one is on continuous cash flow, which is a cash flow of the same amount. So value of perpetuity is equal to present value of perpetuity. Okay, so perpetuity, the present value, is actually equal to amount over r. So this is it, the present value of perpetuity, amount over r. Okay, so this is just about the end of annuities, where we're looking at the types of annuities that we can go for and the whatever goes on. So here we have student loan payments for annuities, examples of annuities, student loan payments, local insurance, premium, mortgage, and retirement savings. Okay, passive annuities at the end of a period for ordinary, end of period 1, period 2. Ordinary simply means payments or deposit done at the end. Okay, so this is just about what goes on. Then the other one for the annuities, I simply saying it's where the payments or deposits are done at the beginning for parts of annuity due. So it's a beginning payment for annuity due. Okay, then ordinary, we are simply saying it's at the end of the period, that is for ordinary annuity. So the distinction between the two matters. Then getting down to the formula, we have this for the future value. We have this. These formulas are given. The guy mentioned, like I've given already for the future value of an annuity. We have this one. All right. This is for ordinary annuity, where the payments or deposits made or done at the end of the period, and then the present value. So yeah, find the future value of an annuity for 1,000 because I paid at the end of each year for 3 years at interest rate of. So this one, the future value, for as long as they're saying at the end of each period, meaning that it's ordinary. It's ordinary because they're saying it's at the end. So this is ordinary. All right. When they just mention an exam at the end, so meaning that we need to find the amount, the number of years, 3, and the percentage is 7. So on the solution, we are getting down to this where we say amount is $3,000. Okay. So we have this one at $3,000. Then we have our R, which is 7%. Then we have how many years are we been told? So we can check for the number of years. Okay, so number of years here, 3 years. So number of years is 3. Okay, so N is 3. Okay, so now, or you can have to look at what are they asking us. Okay, for find the future value. Want to find the future value of that. So it's an ordinary annuity because the payments are made at the so future value, interest factor so future value interest factor of annuity, you're simply saying is equal to amount, then 1 plus R to the power N minus 1 over R. So here we are going to say amount is 3,000. So 3,000, then 1.07, excuse me, the power 3 minus 1. All right. Then we divide by the 0.07. So you can find the future value interest factor of that annuity, which is giving us what? So just a multiplication, 1.07 to the power 3 minus 1, then divide by 0.07, and multiply by 3,000. So it's about 9,644.7. So this is the future value factor of an annuity that we need to go for, please. So the formulas you need to really understand. So the future value is 9,000. Okay, so you're getting the total future value interest factor of an annuity. Okay, so this is for each, so at the end of each year for 3 years, how much was it? Was 3,000 was amount. Okay, so 3,000, not it. So this amount was 1,000, not 3,000. So this is 1,000, not 3. So this is 1,000. So meaning the future value factor of an annuity will be just future value interest factor of annuity is actually going to give us 1.07 to the power 3 minus 1 divided by 0.07 times 1,000. So the answer is 3,214.9. So this is it on the future value interest factor of annuity that we need to go for, please. So we can get down to the other example here where we look at the future value of an ordinary annuity can be viewed as occurring at the end of the last of the cash flows period, whereas the future value of annuity due can be at the beginning, like I mentioned. So annuity due, if it was annuity due, an example, find the future value of an annuity due, okay, where 1,000 is paid at the beginning of each year for the next than that. So meaning it carries an extra interest. So meaning that future value interest factor annuity due. So future value interest factor annuity due So meaning that this one is going to give us amount, all right? Then open brackets, 1 plus R to the power N minus 1 over R, then multiply by 1 plus R. So here we have a 1,000. So 1,000, then 1.07 to the power 3, then minus 1 over 0.07 multiplied by 1.07. So here the answer is going to be 1.07 to the power 3 minus 1 divided by 0.07 times 1.07, then times 1,000. So it's 3,400. Okay, 39, then 0.943. This is the future value interest factor annuity due. Please, you have to take note of this, what is going on here. So 3,000. Okay, so 3,000. So meaning that this is only, okay, so we're talking about this as the future value interest factor annuity due is giving us that amount. Okay, for that given problem. Okay, then the ordinary annuity present value. Okay, so and then getting down to the other one. So the present value is just discount, it's opposite. So present value, if you are given of this ordinary annuity where the payments are done at the end, the present value annuity, okay, so meaning the present value annuity, so present value interest factor annuity, so a present value interest factor of annuity is actually going to be amount, then 1 minus 1 plus R to the power negative N over R. If it is just ordinary, so this is for ordinary. Okay, so it's when payments are done at the end of the period. So meaning that our present value interest factor annuity is actually going to be amount is 1,000. Then 1 minus 1.07 to the power negative 3. Then over our R is 0.07. This is just about what we have. So present value interest factor annuity is actually going to give us 1 minus 1.07 to the power negative 3 divided by 0.07 multiplied by 1,000. So it's giving us 2,624.316. So if it's a present value interest factor annuity due, carries an extra interest. So a present value interest factor annuity due. So meaning that it's going to give us the amount, then 1 minus 1 plus R to the power negative N over R, where the payments are done at the beginning, then multiplied by 1 plus R. So meaning amount would have been 1,000, then 1 minus 1.07 to the power negative 3, okay, over the 0.07. Then here multiplied by 1.07. Then this is the present value interest factor annuity due. So we can sort out this. This one multiplied by 1.07 is giving us 2,000 808 0.018. Okay, 0.018. This is about what goes on as we are looking at the present value interest factor annuity due. So this is just one thing we really need to understand as we are looking at this present value interest factor annuity due is at the beginning of the period. So anything else, when you're talking about the beginning of the period, you look at the present value interest factor annuity due, and then the other one is at the end. All right, so this is just what goes on. So if you want to find the future value interest factor annuity due, provided that information, we are going to have now future value interest factor annuity due, which is going to give us our amount of annuity. Then we have 1 plus R to the power n minus 1 over R. Then here you multiply this one by 1 plus R. So this is it on the due aspect, where we are going to say an amount is 1,000 here. So 1 pin, then 1.07, okay, to the power 3, then minus 1 over the 0.07, then whatever it is multiplied by 1.07. This is on finding the future value interest factor annuity due. Then from here, we can actually finish up. Okay, so this is 1.07 to the power 3 minus 1, then divide by 0.07, and multiply by 1,000, and multiply by 1.07. This is 3,439. Okay, 0.943 for the due of the future value. So this is just about what goes on as we getting down to these annuities. The formulas are given, so it's just in the matter of going through anything else that we need to go through, please. All right. So now getting down to the amortization. So here we just have to look at the beginning, it's an annuity due. At the end is ordinary annuity. So this is a steps to solve a time value of money. Read problems thoroughly, create a timeline, put cash flows and thorough arrows on time, and all that. So we are now getting down. Let's get down to the last part of the time value of money, where we look at the a perpetuity. I mentioned is a continuous cash flow. Okay, and all of perpetuity is equal to amount, perpetuity value of perpetuity is equal to amount over interest rate, which is over R. This is how you get the value of perpetuity, amount over annuity over interest rate. This is how you get to the value of perpetuity, okay, which is equal to this. Okay, so now we are getting down to, okay, amortization. Let's get into amortization of a loan. Okay, an amortization of a loan looks at the breaking down or paying off or liquidating a loan in equal installments at a fixed intervals over the lifetime or loan obligation. The liquidation can be shown through amortization schedule. All right, so steps for amortization schedule, the payment per period. That's a step. You have to look at the breakdown of a loan. So calculate the payment per period, determine the interest rate in that period, then getting down to compute the principal payment in that period, then determine the ending balance in that period. All right, so now prepare a schedule for amortization for a loan of 1,000 kwacha that has been there. Okay, interest rate charged at 6% per annum, 3 years. Amount is 1,000, 3 years, 6% annual interest rate. So we need to find the repayment period, giving that data, and then see to read that we have a zero balance. We've got a 1,000 kwacha loan that you're supposed to pay in 3 years at the interest rate of 6%. So we can create the schedule for amortization that we need to know at which schedule, or looking at anything else that we need. All right. So now getting down to this breakdown, we can sort out this based on whatever it is that we have. Okay. So what is happening is we can sort out. Okay, we can sort out or anything else that we have. Okay, so let us see how we are going to do it. So we have here, what we have is we have actually been given, we've gotten a loan of 1,000 that we need to see how we're going to amortize, how we're going to amortize, how we're going to amortize it. Okay, based on the information that has been given, the interest rate has been given, so we can check whatever it is we have. Okay, so let us see. What amount has we gotten? Amount is 1,000 kwacha. Then our rate that we have gotten from a bank is 6%. And our N is 3 years. So you can find a product repayment, which is our R is equal to amount R over 1 minus 1 plus R to the power negative N. So this is the formula to use for periodic repayment. So our repayment is actually going to give us the 1,000 that we have. Okay. Then our rate is 0.06 over 1 minus 1.06, then to the power negative 3. Then from here, you can find our R, which is giving us, okay? So it's as good as saying 1,000 multiplied by 0.06, which is 60, okay, 60 over 1 minus 1.06 to the power negative 3, 0.1 something something, so 0.1603.80717. So our 60 divided by answer 374.11. So our R is equal to 374.11. Okay, so that's our periodic repayment. Now we are getting down to this, and then we can look at the loan amortization schedule, loan schedule. So on our loan schedule, what is going to happen is we are going to have the period. Okay, so loan schedule is we're going to have a period which will be 1, 2, and 3. Okay, so we have 1, 2, and 3. Then we have the other aspect here we are going to look at is the principal at the beginning. So we have the principal. Okay. At beginning, then we get into the other agenda here. So here we have interest paid. So we have interest paid. Then getting down to the other one is periodic repayment. Periodic repayment. Okay, then we have the other aspect where we look at principal paid, principal paid. Then we have the loan balance. We have the loan balance. So this is the format that we need to go for as we are getting down to this one. So here is 1,000. The interest paid is 1,000 times 6 to 1,000 times 0.6 or 0.06, that is. So it's 60. So you're getting a 60 here. The periodic repayment is 374.11, which is 374.11, 374.11. The principal paid is 374.11 minus 60. So we paid the 314. The bank are claiming that that money is there. So the balance here is 1,000 minus that, which is 685.89. So this is about the loan balance. So meaning principal paid, you are simply saying 374.11 minus 60. So we are getting the 314.11. Then here they have this balance 685.89. Then multiplies by 0.06. So we're getting 41.15. So the principal paid is 374.11 minus 41.15, 332, 332.
Einstein.
Yes, please.
Where have you gotten this 8689?
Go again.
685.
685.
685. Oh, okay. It's the balance this side. Okay.
Yeah, have you gotten it?
Yes, I've seen it. Okay.
So this is a format for loan amortization. So the beginning principal is 1,000. You've gotten a loan of 1 pin, and the interest rate is a better. Are you okay with the 374.11? Are you okay with this figure? How I got it from?
Correct. That one I'm okay.
Yeah. So the principal paid is just the bank are claiming that the 60 kwacha, this is their money. So from this amount, the 60 kwacha goes to the bank, they've gotten it. So they are just telling you that you have only towards the principal, you have only paid the 314, which is this one. Then the balance is 1,000 minus the 314, which is 685.89, which is the beginning for this. You multiply this one by 6%, you are getting this interest. So the payment is this one. So we are going to say now 685.89 minus the answer there with 352. So you're getting the 352.93. So this one is a balance which will come here 352.93. Okay, then multiply this one by 0.06. The interest you've paid is only 21.1 8. Then you can subtract the 374.11 minus 21.18. It's about 352 point what? 352.93. Meaning we're going to have a zero balance there. When you subtract this 1 minus that, you're going to have a zero. You would have finished paying the loan in 3 years' time. So the number of years that that is indicated there is the time taken for an individual to finish paying for the loan. All right, so this is about time value of money that you really need to understand. Loan amortization is a very, very important part of the time value of money, that as you look at corporate finance, company finance, this question comes: what is important for you to understand the concept is what is very, very important. So just look at the format. This format will help you give you a guide on how you prepare the schedule for anything else. So if you go to the bank and borrow from anywhere else, and then if you are thinking as if they are overcharging you or anything else on the schedule, this is how you prepare this schedule. You can do a manual computation on the periodic repayment based on this formula here. You substitute the figure, find this on your own, and then see how the schedule will be. Not only that, this is based on annual compounding. This is on annual, but you find that when they say monthly, the formula changes just a little bit. The R is divided by 12. The same formula applies for monthly compounding. This one was on annual compounding. So monthly compounding, the interest rate is affected. So what I mean is that our payment for monthly will be the formula in the question. When they give you monthly, will be amount R over 12, then over 1 minus R over 12. Okay, 1 plus R over 12, then to the power negative 12. All right, this is only the monthly compounding of a loan amortization. If they say quarterly, you divide that R by 4. All right, so here it was annual, and we are doing it the way we have done it because it's the loan schedule that has been done based on annual compounding, which means the interest rate, the formula applies the same way it is. So if they say quarterly, you divide where you have the R there, you divide that R by 4, it's quarterly. Semi-annually, you divide by 2. For monthly, you divide by 12. All right, so the examiner can only ask you to go for the annually one, or you can ask you to go for semi-annually, you divide by 2, or quarterly or monthly. Of course, the day-to-day running of the business, when you get a loan from the bank, they deduct from your payslip based on monthly. But be mindful on the question, what the question is all about. If they say, yeah, it's annually, don't let it be. You use this formula for annually. If they say monthly, you just follow instructions of how the examiner phrase the question, unless there are any other questions. But on amortization, go through whatever it is that I've explained. You will never go wrong. So we can end here for now.
Thank you so much. Sten.
Yes.
Okay, I think you can end. You've stopped recording, right?